Hello students, welcome to SANKALP CET classes. So today we are discussing mathematical reasoning. So the first definition, that is proposition or statement. So what is a mathematical statement or a proposition? A declarative sentence which is true or false but not both is called as a mathematical statement, or it is called as a proposition. So either the sentence must be true or false. It should not be both. So such a sentence or a declarative sentence is called as a statement. So the sun sets in the west. So it is a true statement. Every even number is divisible by 4, etc. The sentences which include questions, exclamation, expressions of opinion are not propositions. For example, the following are not propositions. So if a sentence is having a question mark, exclamation mark, okay, or an expression of opinion or request, then it is not a proposition. Are you attending the college function? There is a question mark, so this is not a statement. Oh, what a beautiful flower it is. Again, it is not a statement. Wish you good luck in the examination. Okay, again, it is not a statement. The propositions are usually denoted by small letters P, Q, R, etc. So if a proposition P is true, then we say its truth value is T. And if it is false, then we say its truth value is F. Logical connective and compound propositions. The words and, or, not, if, then, if and only if are called logical connectives. These are respectively denoted by and, or, negation, if, then, if and only if. So a compound statement, a proposition containing one or more connectives is called a compound statement. The statements used to construct a compound proposition are called as components. Okay, so these simple sentences, the examples, what we discussed here, the sun sets in the west, is a component. It is not mixed up with any connective. So when we connect such 2 or 3 sentences with the help of these connectives, then it will form a compound statement. Example, phi is prime or a composite number. So we have used the connective or. Okay. If x is equal to 4, then x square is equal to 4. Abhijit is practical and quiet. So and is the connective. If two triangles are similar, then their corresponding angles are equal. Fundamental of forming the compound proposition. So first one is a conjunction. Okay, conjunction, or also it is denoted by this symbol. Next, next point, the conjunction of two proposition P and Q is true if both P and Q are true. In all other case, it is false. So it is true only if P and Q, both the components are true, and it is false in rest of the cases. Next, disjunction. If P and Q are two propositions, then the compound proposition P or Q is known as disjunction of P and Q, and it is denoted by P and P or Q. The disjunction of two propositions P and Q is false if both P and Q are false, and in all other cases it is true. Next, negation. If P is any proposition, then the proposition not P is called the negation of P and is denoted by negation of P. If a proposition P is true, then its negation is not P is false, and if P is false, then negation of P is true. Fourth one is a conditional. If P and Q be two proposition, the compound proposition if P then Q is known as the conditional of P and Q, and it is denoted by P implies Q and read as if P and then Q. If P and then Q. The conditional is false whenever P is true and Q is false, and in all the other cases it is true. So here in the figure you can see the first table represents. Last one is biconditional. If P and Q be two propositions, the compound proposition P if and only if Q is called a biconditional proposition and is denoted by P double implication Q, read as P if and only if Q. Clearly, P double implication Q is equivalent to P implies Q and Q implies P. The biconditional P double implication Q is true only when P and Q are both true or false. That is, if P and Q have the same truth values. So the first, these are the truth values for P and Q, T, T, F, F, and Q is T, F, T, F. So when we combine the truth values of P and Q using AND, you can see it is true only in first case, rest of the three cases it is false. For OR, you can see it is true in the three cases, only in last case when both are F and F, the truth value is false. Negation, just you need to go on writing the reverse. Next, P implies Q. P implies Q is T, F, T, T. T, F, T, T. That is, it is true always. Only when Q is false, it is false. The rest of the case, it is true. Next, double implication. So double implication, see if it is T and T, it is T. F and F is also T. But biconditionals means both side you should have the same, either TT or FF. Then you get the truth value as T and T. But if one is T, another is F, then you get false, false. Next, logical equivalence. Two compound proposition involving same components are said to be logically equivalent if their truth values are same. Okay, if their truth values are same. So if the truth values of two compound propositions are same, then such compound propositions are called as logically equivalent. The two compound propositions are said to be logically equivalent if their truth values are identical. The two logical equivalent proposition P and Q are represented by P. There are three lines implies Q. So it is read as P is logically equivalent to Q. Next, list of some important logical equivalent propositions. P or P, it is equal to P, and P is also equal to P. It is the idempotent law. Next, law of double negation. Negation of P is equal to P. P or Q is equal to Q or P. P and Q is equal to Q and P. Commutative law. Associative law, we have three components. P or Q or R is equal to P or Q or R. Similarly for AND. Next, distributive law. P and Q or Q is equal to P and Q or P and R. Similarly, P or Q and R is equal to P or Q and P and R. Distributive law. Next, law, De Morgan's law. Negation of P and Q is equal to negation of P or negation of Q. Negation of P or Q is equal to negation of P or will get converted into AND. Negation of P implication Q. P and a negation of Q. P implies Q, a negation of P or Q. P implies Q and R. P implies Q and Q. P implies R. Next, negation of P double implication Q is equal to P and double implication negation of Q. Next, converse, inverse, and contrapositive of conditional. P implies Q, be conditional, then converse, inverse, and contrapositive of a conditional statement. So P implies Q, be conditional, then Q implies P is called the converse of P implies Q. The conditional negation of P implies a negation of Q is called the inverse of P implies Q. The conditional negation of P implies negation of Q is called as the contrapositive of P implies Q. The truth table of the conditional P implies Q, its converse, inverse, and contrapositive are given below. So from the above table, we can see that P implies Q is equivalent to contrapositive statement, and Q implies P is equivalent to inverse of the statement, conditional statement. A condition and its contrapositive are equivalent. The converse and the inverse of conditional are equivalent statements. Next, tautology and contradiction. A compound proposition is said to be a tautology if it's always true for all possible combination of the truth values of its components. A compound proposition is said to be a contradiction if it is always false. Okay, so if the final answer, if you are getting always true, then it is said to be a tautology. If all these truth values are true, all are true, then it is said to be tautology. If all are false, if all the truth values in the last column are false, then it is said to be contradiction. Next, T and P, double implication P, where T is tautology, is a tautology. C and P, double implication C, where C is a contradiction, is a tautology. Two statements P and Q are logically equivalent if and only if P double implication Q is a tautology. P is equivalent to Q implies P double implication Q is a tautology. Next, we will discuss few examples related to the above points. So the first question is, so which of the following is not a proposition? Wish you good luck in the examination. Red Fort is in Mumbai. 3 plus 7 is greater than 4 plus 1. Similar triangles are congruent. So B, C, and D are, see, statement B is false, statement C is true, and statement D is again false. So all these three, B, C, and D, are giving one value, that is either true or false. But wish you good luck in the examination. It is just opinion of a person. Okay, so the option A is the right option. It is not a proposition. Okay, it is not a proposition. So we have discussed if a sentence is starting with an exclamation mark, a question mark, or it is having a word of request or order, then it is not a proposition. Next, Example number 2. The negation of the statement, if a quadrilateral is a square, then it is a rhombus is. Okay, so we need to write the negation. So the negation of the given statement, is, see, if P implies Q, if P implies Q, if we have P implies Q, P implies Q, that is if then the negation of this, okay, then the negation of this is equal to P and negation of Q, okay, P and negation of Q. So see, P and negation of Q, P as it is, A is a quadrilateral, and negation of Q, it is reverse of this, it is not a rhombus, okay, it is not a rhombus. So out of the given option, okay, out of the given option, the answer C is the right option. A quadrilateral is a square and it is not a rhombus, okay, and it is not a rhombus. Next example. The next question is the contrapositive of the statement, if x square minus 1 equal to 0, then x is equal to minus 1 or x is equal to 1. So the contrapositive form of the given conditional statement is written as, okay, the given statement is written as, so the contrapositive part of the statement is given by, so if P implies Q is a statement, then contrapositive part is negation of Q implies negation of P, okay. And so in this statement, see, if then is getting replaced by, if then only, there is no change, only x is equal to minus 1 will get replaced by not minus 1, and or will get replaced by and, or will get replaced by and. So if we compare the conditions, so this second statement will be considered as first with its negation. So if x not equal to minus 1 and, or negation is and, x not equal to 1, then x square minus 1 is not equal to 0. So the option D is the contrapositive form of the given statement, Next question, the proposition P implies negation of P and negation of P implies negation of Q is, okay. So we will check it by constructing a truth table. By constructing the truth table, we can check the truth value, whether it is tautology or contradiction. So first I'll consider P and then negation of P. So P negation of P. See, P has two values, T and F. Okay, it has two values, T and F. So negation of P will be opposite of T, that is false, and negation of F will be T. So first case we have P implication, negation of P. So implication, so T implies F will be F, okay, and F implies T will be T. Next we have negation of P implies P, negation of P implies P. So negation of P implies P will be equal to, negation of P implies P will be equal to, we have negation of P implies P is equal to negation of P, F implies T is T, and T implies F is F. And then when we connect this using the connective and, it is the connective and, so if we connect both the statement, P implies negation of P and negation of P implies P. So if we combine both the statement, we get, see, T, F implies T is T, and T implies F. Okay, so T implies F is, so using the AND operator, F and T, the value of the function will be false, and again T and F, again it will be false. Okay, because it is true when both are true. So we are getting the final answer as F and F. So the option B is the right option, that is a contradiction. It is the contradiction. The given statement is a contradiction. Next question. Let P be the proposition Delhi is in Karnataka and Q be the proposition Mumbai in MP. The symbol P implies negation of Q means, okay, P implies a negation of Q means, okay. So see P and this symbol, it indicates if then, okay. So if Delhi is in Karnataka, then Mumbai is not in MP, okay. Then Mumbai is not in MP. So the option A is the right answer. Option A is the right answer. Next question. So let P denote the proposition sunset is east, sun sets in east, and Q be the proposition 2 plus 7 is equal to 8. And then the symbol Q implies P means, okay, Q implies P. So first Q and then P. So if 2 plus 7 is equal to 8, then sun sets in the east. Sun sets in the east. So the option B is the right option. Option B is the right option. So now in the next question, three statements have been given, P, Q, and R. Then the symbol P implies Q and R means. So see P implication Q and R. So implication is there. So if then condition. So if Suraj passes in exams, then Professor X resigns from the job, or, but here instead of or we have and. So instead of R, if we consider and, as in the second question, if Suraj passes in mathematics, then Professor X resigns the job and college will conduct an inquiry. Okay, so the option B, okay, option B gives the right symbolic meaning of P double implication Q and R. Okay, so the next question. Next question, if x minus 2 equal to 3 and y equal to minus 2, then 2x plus y is equal to 3. The contrapositive of this statement is, okay. So contrapositive, a negation of Q implies negation of P. So this is a negation of, this is the negation of Q part, and these are negation of p parts. So contrapositive, it is just the reciprocal of q, and x minus 2 equal to 3, y is equal to 3. So contrapositive, we need to take the negation. So negation of this will be 2x plus 3 not equal to 3. 2x plus 3 is not equal to 3 is in all way every options. So here you can see y equal to minus 2, then 2x plus y equal to 3. The contrapositive of this statement is is contrapositive. So negation of the first and here and will change into or alphabet. So the option B is the right option. Option B is the right option. Next question, the contrapositive of the statement, if 7 is greater than 5, then 8 is greater than 6. Okay, so if 8 is not greater than 6, then 7 is greater than 5. So the contrapositive of the statement, if 8 is, okay, see, we need to take the negation of this. 8 is not greater than 6. 7 is higher than 5. 7 is higher than 5. So it will be 7 is greater than 5. 7 is greater than 5. So the next question is the contrapositive of the statement, if 7 is greater than 5, then 8 is greater than 6. So we always, in case of contrapositive, we need to use the condition. The symbolic condition is what? Negation of q implies negation of p. Okay, negation of q implies negation of p. So if 18 is not taller than 6, then it is greater than 6. So if f is not greater than 6, so the question is contrapositive. So negation of q implies negation of p. So say 8 is not greater than 6, 8 is not greater than 2 cases we have, and then if 7 is greater than 5, then 8 is greater than 6. Okay, so here the contrapositive of this given statement will be if 8 is not greater than 6, then 7 is greater than 5. Then 7 is greater than 7 is not greater than 5. So the option C gives us the correct answer. Next question. So the next question is the statement, if x square is not even, then x is not even. We need to write the converse. Okay. So in case of converse, we need to make use of the formula in case of converse. we are making use of the formula. If P implies Q, then converse is Q implies P. So Q implies P will be X. Q implies P. If X is not even, then X square is not even. Okay. So the option B gives us the right answer. Next question. Next question. The compound statement P and Q implies P or Q is. Okay. So we will check it using the truth table. So using the truth table, we can write the values of P, Q, and R. So see the truth values of P and Q. T, T, F, and F. This is T, F, T, and F. Okay, T and F. Okay. So here on combining, what do we get? TF, TF. So first is P or Q. Okay, P or Q, we know it is T, 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 and one is false, plus and is 3 times T. One is false. Okay. So when we apply implication, we get everywhere as T. Okay, we get everywhere as T. So the option A is the right option. Option A gives us the right answer. Next question. T and double implication P, where T is a tautology is. Okay. So again, we will check the truth table and decide whether it is a tautology or a contradiction. So here in this case, the given equation is, the given statement is, see T and P, double implication P. So here T, see T will be true and true. Negation of P, it will be F. Okay, so to form the truth table, we require the values of T and P. So T is always true. So T and P I have written. Okay, so P, once we are considering a truth value, once we are considering a false value. So on simplifying further, so one of the value is T, another value is false. So when we combine it using the result and double implication P. So we are first I will combine the result. T and P. So T and P will be equal to, see T and P, T and P will be equal to T and P. So this is true and this is false, and then double implication with P again. So P is T and F. So on simplifying, see double implication, and that is negation of T. So on double implication, so say T double implication T is also TF double implication, this is also T. Okay, so in both the cases we are getting truth value, and this is the final answer for T and P. double implication P. Okay, double implication P. So both are true. So the option A is the right option. Option A is the right option. Next question, C and P, double implication C, where C is a contradiction, is a tautology contradiction. Okay, so when you again make use of the same steps what we did for the previous exercise and simplify, we get the answer as a tautology. Okay, as a tautology. So the next question is, the diagonals of a rhombus are perpendicular. The contrapositive of this statement is, if the figure is not rhombus, then its diagonals are not perpendicular. So here we can say, if the diagonals are not perpendicular, then the figure is a rhombus. Then the figure is a rhombus. So the option, if the diagonals are not perpendicular, then the figure is a rhombus. Okay, so in both the cases we need to use not. We need to use not. So the right option is the diagonals of the rhombus are perpendicular. Contrapositive, if the diagonals are not perpendicular, then the figure is not a rhombus. Okay, so the final answer will be option D. Option D will be the right answer. Next question. The next question, negation of the statement, plants take in oxygen, carbon dioxide and give O2. So here in this particular statement, plants take in oxygen and give. So here we have two statements. Say P and Q. We need to take the negation of this. Okay, so it will be negation of P. Okay, or negation of Q. Negation of P or negation of Q. So the negation will be plants do not take in CO2 or don't give O2. Okay, so here and will get replaced by or, R will get replaced by or. So do not and do not. So out of the given option, option B is the right answer. Option B is a right answer. Next example. The next question is the negation of the statement Rajesh or Rajni lived in Bangalore is. Okay, negation of this. Rajesh or Rajni lived in Bangalore. Lived in Bangalore. So Rajesh did not live in Bangalore, and Rajni did not live in Bangalore. Rajni did not live in Bangalore. So the negation of or will be and. Okay, or will be and. So Rajesh did not. Okay, so Rajesh did not live in Bangalore, or is and Rajni did not live in Bangalore. Okay, so the option C is the right answer. Option C is the right answer. Okay, next question. So next question is, it is not true that roses are yellow implies violets are green. The simplified form of this statement is simplified form of this statement is okay. So yellow roses are yellow, pimples are white. So roses are yellow and the violets are green. And the violets are green. It is not true that. Okay. So out of the given options, roses are yellow implies violets are green. This simplified form of the statement is okay. Form of the statement is roses are yellow and why say violets are green. Violets are green. So 24. Okay, so the option D is the right answer. Roses are yellow, violets are green. So the simplified form is so roses are yellow implies violets are green. Roses are yellow and violets are green. Okay, so this will be the right option. Option A will give us the right option. Option A. Next example. So these were few examples based on mathematical reasoning. Okay, so the chapter is little theoretical. You need to know the conditions for the tables of and, or, if, then, if and only if. But one question is every year occurring in CET as well as in JEE level. So again, solve some more examples and get ready for the competitive exams. Thank you.